Good morning. I'm going to show you a video on how to do the problems in 8.1. So we've moved on from what we did last time, which was confidence intervals, and now we're going to hypotheses test. They kind of go hand in hand with each other because as we had three different types of confidence intervals, we'll have three different types of hypothesis testing. So for 8.1, we're looking at it's called z-test. And the reason it's called z-test is because we're using the z-table. So let's take a look at this problem and see what we can find out. Gentle Ben is a Morgan horse at a Colorado dude ranch. Over the past 8 weeks, a veterinarian took the following glucose readings for this horse, and it gives it to us, his glucose. The sample mean is 93.6. So that sample mean is all of these values. They put it together, they found the average, and that's what they got. Let X be a random variable representing glucose readings taken for Gentle Ben. You may assume that X has a normal distribution. Okay, so that's a key there. It's saying that it follows that normal shape. And we know from past experience, the population standard deviation is 12.5. All right, that's huge. And I'm going to highlight it. I know you probably think I'm a dork for doing that, but all right, let me go here. Okay, I highlighted it. And I'm going to go back here and I'm going to highlight this sample mean. Okay, all this is going to be important in just a minute. All right, the mean glucose level for horses should be 85. Okay. Does the data indicate that Gentle Ben has an overall average glucose level higher than 85%? Use a significance level of 0.05. All right, so what I'm going to do here, I'm going to make my life easier, and I'm going to make a list of everything I have. So I have a sample mean, which is 93.6. I have a population standard deviation of 12.5. Then I have a population mean of 85, and I have a level of significance, and that equals 0.5. Okay, so I have divided my question up. I'm not going to need this data up here because I'm given my population standard deviation. Okay, this is very, very important. Since I have this, I can run a z-test, as we call it, okay? All right, so let's keep going. What is the level of significance? Oh, right there. It was already in the problem. Most of these problems, I'm hoping, already have them for you so that you know exactly what it is. All right, state the null and alternative hypothesis. Will you use a left tail, right tail, or two tail? Okay, so you're going to have a null, and then they have the alternative. You might see this if you're looking at Khan Academy videos or different things. The null is always going to be HO. The alternative could be H1 or HA. It just depends. This is kind of a thing that statisticians, you love one way or the other. For this class, this is the only thing you have to worry about. Okay, so in the null hypothesis, you're always going to have, for this class, your equal sign. Okay, oops. I don't want to do that. Let me go back and I'm going to show you. I'm going to insert the little mu so you know what it is. Okay, so there's the mu. Let me make this bigger. Okay, mu equals, okay, it's always going to equal your population mean. And my population mean is 85. All right, here is a trick. I know it's kind of stupid, but just go with me on it. The word null, if I flip it on its side, the last two letters form an equal sign. So that's how I always know to myself, this is the null, it always has the equal sign. All right, so then I have to do the next part. So I've got my little mu in there again. Okay, this is where it's directional. It can be less than, greater than, or not equal. Well, here it's saying, is it higher than 85? And I'm going to go back and highlight this. I'm going to do this as a different color, and I'll show you why in a few minutes. All right, higher. Higher is the same thing as above or greater than. So this one is going to be greater than 85. Okay, And I know it looks a little bit different. Sorry about that, but there we go. Those are my two hypotheses. All right. So if I look here, I want to know if it's greater. So, yep. Okay. All right. All right. So remember, do I want to know if Gentle Ben has an overall glucose level higher than 85? And that is the same thing as that. Does that make sense? It's this one that I'm looking at. So because it's got the greater symbol, it's a right-tailed test. Okay? If you don't remember what these are, if it's less than, that's a left-tailed test. If it's greater than, that's a right-tailed test. Oops, it'd be nice if I could spell this morning. And then the one that throws some people off is not equal. Okay, that is a two-tailed. Why is it two-tailed? Well, remember when we did normal distribution and you had the situations where things were in the middle and you had two things on the side? That's what it is. These kind of questions will be like, is there any difference in blood sugar? Is there any difference in the mean age of students driving and our students taking classes? It's something that's not given a directional tell. They just want to know if there's a difference or not. All right, so here we go. Let's keep going. Okay, down here, what sampling distribution will you use? All right, so let's go up here. Remember I said I had written all my stuff out and I had population standard deviation equals 12.5. If you have the population standard deviation, that triumphs a t-test, which you'll see in 8.2. Remember from confidence intervals, if you had that population standard deviation, you do a z-interval. All right, for us on that one then, I don't care about the student t, so I don't need to look at that one because this isn't a student t. So here's the other ones. The standard normal, since we assume x has a normal distribution with an unknown population standard deviation. This one is not that because we know it. How do we know it? It was given in the problem right here. And that's why I put all my stuff up here so I don't have to go back to this nasty word problem. It's all right there. All right, so I'm going to do this. Okay, so then it says now compute the z and find the p. All right, I'm bringing up my calculator. And let me go back up so I can make sure I've got everything in there. And I'll show you where this helps me. I'm going to turn my calculator on. All right, so here we go. I'm going to go to stats. I'm going to go over to test, and I'm going to hit z-test. This is really important. Because I have that population standard deviation, I'm going to run a z-test. All right, so I'm going to input, and I'm going to do stats because I was given all the stats. You can run this with the data if you want. You just click on this, hit enter, and then make sure before that you've put all your data in where you need to. This should be familiar from when you did t-interval, but I'm just going to do stats now. I'm going to hit stats. Okay, what's my population mean? 85. What's my population standard deviation? 12.5. What's my sample mean? 93.6. And what's my n? So I'm going to count this. 1, 2, 3, 4, 5, 6, 7, 8. And it's here too, 8 weeks. Okay. This down here is looking for your alternative. So what was the sign of my alternative? It was the greater than, and I see it down here. If you understand why I write everything out, it's so when I do this, I don't make any mistakes. I have everything lined up. So then I'm going to go down. So another thing about this, when you're here, it'll blink. To make sure you get it, you have to hit enter. So then when you go down, it's highlighting the thing you look. If you don't make sure of that when you keep going, it will always default to two tails. Hit calculate. Ooh, so I've got some stuff. Okay, I've got a z value right here and a p value. So let's do this. I'm going to copy it into my document just so I have it, right? I'm going to copy this. All right. All right, got it. And we're going to keep going. All right, so I'm going to keep going down here. All right, so now I'm going to bring this down. Okay. All All right, so now here, okay, it says it wants your Z value, or your Z's value. So it's right here, and it wants 2 decimal places, so it's 1.945. Well, that becomes 1.95. So I know my Z value is 1.95. Okay, P value. Oh, look, it's just right there. Okay, and it wants 4 decimal places. So I get P equals 0.0258. Okay, so that's my P value. And I'm really, when I teach this face-to-face, I always am very exact and call it the P value because we use proportions and people can get confused. All right, so there it is. Again, check yourself. Does this visual right here match your alternative? And it does. Those kind of things. Check yourself to see that you got the right answer. All right. All right. So there's my Z and there's my P value. All right. I'm going to keep going. So it wants me to find the sampling distribution for this. Okay. You already told me up here it was a right-tailed test. So right tail means greater than. So let's look at the drawings. Okay. It could be this one. I know it's not this one because it's a two-tailed and I'm not doing a two-tailed test. This one is kind of weird, oops, because it says it's looking for everything in this area. Maybe that's it, and this is a left-tailed and I don't want it. All right, so remember we talked about that level of significance, and I'm going to put it right here. So my level of significance was 0.5, and it was a right-tailed test. So it's trying to find values that will fall in this area right here. It's not trying to find areas that fall in, oops, sorry, this area right here. Okay, sorry about that. So the answer is this one right here. This is your answer because level of significance is 0.5. And if I looked at that on a table, that would be it. That's 0.5 of the total 100% here. And it's a right-tailed test and it's going to the right. So that's your answer. If it had been a left-tailed test, oops, it would have been this one. Come on, quit, computer. And then if it had been a two-tailed, it would have been that one. Okay, I hope that helps on that. All right, so let's keep going. All right, down here. I know this is long, sorry. All right. Ignore this dot. It got put in there accidentally. All right, so will you reject, fail, or will you reject or fail to reject the null, and is the data significant? All right, so let's look at this. I do a really stupid thing. Bear with me, but it might help. Okay, so if P is less than or equal to the level of significance, comma, you reject the null. Okay, the way I remember this is I kind of remember the opposite. Okay, and it's really kind of crazy. People getting eaten by fish, thinking of sharks, guys, you fail to reject the null. Okay, so if I know that the only time you're going to fail to reject the null is when P is greater than alpha, then every other time it's reject the null. All right, so let's look at this. My P was 0.0258, and I'm going to look at my level of significance. Oops. Let's do this 0.05. Okay, that can sometimes be tricky. All I do is I put extra zeros so that I have the same number of decimal places, and it makes it easier to look at. So is 258 smaller than 500? It is. So I'm going to put in my stuff, and I'm going to say we reject the null. Okay, so I'm going to reject the null. So I'm going to go back up here first. So I've got my stuff here. Okay. Oops. Remember I said I had my green? All right. So I'm going to call this my OC, which is my original claim. Okay. All right. So I rejected the null, which meant the null was false. and the alternative was true. Okay, so that means here, my original claim is true. Hold on, let me make it bigger. Okay, it means my original claim is true. Oh, so that means it is significant. So if I go back down here, okay, and look at my choices. Okay, oops, quit. Sorry, my computer's being weird today. Okay, oh, quit. All right, here you go. All right, so which one will I pick? All right, I did reject the null, and I did find it supported my original claim, so A is true. I didn't fail to reject the null, so this one's not true, this one's not true. But when the reason that I got reject the null and concluded the data was statistically significant is because it was that original claim and I supported it. So when you do these, make sure to put like OC next to the original claim, and then if it's true or false, it tells you if you're supporting it or not. All right, so here I am. I've got to figure out how I'm going to conclude this. Let me put it here. Okay. All right, so let's go back up and let's talk about it. All right, I told you I supported it. I told you my original claim was true. So that means, yes, his blood sugar is higher than 85. And if you look at the sample mean, you can see that it actually is, but you can't always go by that because of the population standard deviation. Remember, population standard deviation tells you how spread out your data is. All right, I hope that helped. And let's go back down here. All right, so what am I going to say? Yeah, there was significant evidence to conclude that his blood sugar was higher. There was, because if I go, so it's, for me, it's the first answer. Yours might be different. So it is. There is significant evidence. Woo! My computer's acting all weird today. Okay, so there is significant evidence that it was higher. And again, how did I know that? Because of this right here. It supported my original claim and it was true. Okay, that was 8.1.